So this question is about the emission of photoelectrons. So we've got photoelectrons emitted from a sodium surface when it's illuminated with monochromatic electromagnetic radiation. Stopping potential given is 3.42 volts. Show the maximum kinetic energy is given by 5.5 times 10 to the negative 19. So we know that the maximum Ke is the HF, take away the work function. But actually we can go straight from this because the stopping potential effectively takes away all of the Ke. So the stopping potential takes away all the Ke. So the energy that we're taking away is QV. So that's the maximum Ke. So we can calculate the maximum Ke by using the stopping potential and the charge on electron. So we end up with 1.60 times 10 to the negative 19 multiplied by the stopping potential, which is 3.42. So I just multiply the charge on electron, 3.42, by, so charge on the stopping potential by the charge on electron, 1.6 times 10 to the negative 19, and I'll get something that should be pretty close to the answer I'm asked to find, 4.72 times 10 to the negative 19 joules. Now, this is a show that question, so we're going to be using this later on in some part of the question later. I would imagine that's usually why you get to show that question. It's so that you can use this value later on. You're not penalised for not being able to calculate it. It then asks us to calculate the wavelength of radiation that's incident on the sodium surface. And we're told the work function of sodium. So we know that this value is this. And then we're trying to find the wavelength, which we can get from the frequency. We know the work function. So we can get that, if we rearrange that equation, we can get that HF equals the kinetic energy plus the work function. And I can express this as, because C is F lambda, I can express HF as HC over lambda, which might sound familiar to you. So HF is the same as HC over lambda. So I can do all of this now. HC over lambda equals Ke plus the work function. And I can do a lot of rearranging. What I'm probably going to do for simplicity is to actually calculate this in EV. So I've got 2.36 EV plus that 3.42 EV. So 3.42, because it's in volts, then I can add that to 2.36, and I get 5.78 EV as that value. So that is my HC over, so that's HF effectively, that's the energy of the photons, and then what I'm asked for is what wavelength does that correspond to? Well, I can rearrange this and I can get that HC over 5.78 EV is equal to lambda. So I'm just going to move back to the top, give myself a bit more room. So I've got that HC over lambda equals 5.78 EV. Therefore, lambda equals HC over 5.78 EV. And then I can calculate that. So I've got 6.63 times 10 to the negative 34 times the speed of light divided by 5.78 times 1.60 times 10 to the negative 19. And I calculate all of those. I can work that out, and that will give me my value for lambda, which ends up as 2.15 times 10 to the negative 7 meters.